In this presentation, we will explore how to create high-quality services by leveraging domain-driven design, functional programming, and clean layered architecture. We will delve into core principles, benefits, and practical application of these methodologies. This presentation, we will cover several key topics, starting with an introduction to domain-driven design, followed by fundamentals of functional programming. We will then examine clean architecture and discuss how to integrate DDD with functional programming. Domain-driven design is a methodology focused on creating software that models complex domains. By emphasizing collaboration between technical and domain experts, DDD promotes building a shared understanding of the domain requirements. The core principles of DDD include focusing on the domain, using a common language, and creating a model that reflects the domain complexities. This approach helps ensure that software aligns closely with business needs. Using DDD in service design enhances flexibility, scalability, and maintainability. It allows developers to better understand the business context and create services that evolve in alignment and domain changes. Key concepts in DDD include entities that have distinct identity, value objects that are immutable and defined by their attributes, aggregates that group entities for consistency, and repositories that handle data persistence. Functional programming is a programming paradigm that treats computation as the evaluation of mathematical function. It emphasizes immutability, first-class functions, and high-order functions. Core concepts of functional programming include pure functions, immutability, and higher order functions. These concepts help in writing predictable and testable code. Functional programming offers benefits such as easier debugging, enhanced code reusability, and improved parallelism. It encourages a more declarative and less error-prone approach to coding. Clean layered architecture is a design pattern that separates concern across different layers, enhancing organization and maintainability. It promotes a clear structure that allows each layer to focus on its responsibilities. Clean architecture principle emphasizes separation of concern and testability. This creates systems that are easier to manage and evolve over time. Clean architecture typically involves 4 layers: presentation, which handles user interaction; application, which contains business logic; domain, which represents the core domain models; and infrastructure, which deals with external systems. It is also called the anti-corruption layer. Decoupling layers and applying dependency inversion principle help reduce tight coupling between components. This allows for easier testing and greater flexibility in choosing implementations. Integrating DDD with functional programming creates powerful systems that leverage the strength of both methodologies. This combination can lead to more robust and maintainable service designs. By applying DDD concepts with the functional paradigm, developers can create clear and concise models that reflect the domain, which benefits from functional techniques to manage complexity. Functional programming allows for elegant modeling of domain logic through the use of pure functions and immutability, fostering cleaner and more predictable behavior in the system. Managing side effects and state in a functional context involves strategies such as using monads or immutability to contain changes, ensuring that functions remain pure and predictable. Implementing clean layered architecture involved structuring services according to the defined layers, ensuring that each layer adheres to its responsibilities and communicates effectively with others. Structuring services with clean architecture layers promote clarity and organization. Each layer can evolve independently, simplifying updates and maintenance. Best practices for maintaining separation of concern include defining clear interface between layers, using dependency injection, and apply design patterns that support modularity. Let's take a look at the functional DDD template. It'll help you write your services using domain-driven design, functional programming, and clean architecture. It also uses EQRS and mediator pattern. So the layers that we have are application layer, API layer, application layer, domain, as well as anti-corruption layer. The API layer also has versioning built in, and service level indicators have been integrated so that every call to a specific API will return its duration and its success or failure status. So let's take a quick look at the code. So this template is based off the weather forecast sample that ships with .NET. And here we have the 4 layers. API is the presentation layer. And then we have the application layer that sits between the presentation layer as well as the domain and contains the commands and queries. And the anti-corruption layer, which is also known as the infrastructure layer. So if we expand on the API has got API versioning integrated, so all the controllers and the models are within this version. So each time you ship, you can have a fixed contract where none of your APIs as well as the models will change. And the API is in a date format. The other thing is that all the method calls will have its time logged as part of OpenTelemetry, and you'll also have the return status. So those things are all configured here. Here we have OpenTelemetry set up, and this is the service level indicator. And location is where your service is running. So if you're multi-region deployment, you want to add different region information so that you know where the telemetry is coming from. And this is the piece that adds the API versioning. Then there is if we come back to the controller, you'll see a method that just throws. So there is a middleware that will handle all the unhandled exceptions and will provide a consistent error message to the user, as well as it'll log this information with trace information so that when the user pings you with the trace ID, you're able to look it up in your logs. Now let's look at the application layer, which contains the command to query the weather forecast. So here's the command called weather forecast query. You create it, you pass it the zip code to which you're interested in, and issue the command. It uses the mediator pattern to call the handler, which in turn uses the anti-corruption layer to get the actual weather. And in our domain, we have the domain model, in which case here we have the zip code. So when you try to create the zip code, it checks whether it is in the US zip code format, otherwise it'll return a validation error. Weather forecast here is an aggregate, and the ID for it is the zip code. So all just a simple boilerplate sample code so people can actually put their business codes around it. When it comes to the anti-corruption layer, we would have the weather forecast service, which returns the weather for a few zip codes. Another feature is using convention over configuration for deployment. So when deploying something like Azure Web App, we just need to set a few properties like environment and say region. So from environment, which could be local development or test PPE or production environment, and then region is whether you're in USA East, West, or UK or some other region. So using these combinations, the specific instance of service is able to figure out where it needs to go to connect to its database or key vault. Since we want regional resiliency, we're going to have Cosmos DB geo-replicated to multiple locations. Similarly, the key vault is going to be in different locations and so on, and Service Bus as an example. So in these scenarios, we don't need app settings to contain the URL to the Cosmos DB or a key vault. The code can figure this out by looking up at the environment option. You still do have the option of changing the name by overriding it using the app settings. But in general, by following this convention, you should have a consistent deployment behavior in your development, test, PP, and prod scenarios. And here we see the railway-oriented concepts provided by functional DDD used here, where we have the railway track and bind methods will only call on the success track. To error action will get called irrespective of success or failure, and it'll take care of returning the right error code. So, for example, when you call create zip code, if the zip code is invalid, that it'll take the fail track and go straight to the action result, and that'll return bad request with the details of the failure. In case of success, it'll go into bind, do the next action of creating this command, and then we dispatch it off to using the mediator pattern. Once the response comes back from the domain, it is mapped to the model, which is our contract here, and then OK result is sent as a response. While implementing DDD and functional programming can be beneficial, organizations often face challenges such as resistance to change and skill gaps. In conclusion, combining domain-driven design, functional programming, and clean architecture provides a robust framework for designing high-quality services. By understanding and applying these methodologies, developers can create systems that are both flexible and maintainable.